I'm Dr. Gabriel Bidaux. I'm working mainly on ischemia-reperfusion syndromes, and because we're working at the hospital, our main aim is to understand the pathology, then to find new targets to help curing, healing patients subjected to these syndromes. What we want to understand is what's happening in the cells, in all cardiac cells, that would lead to failure at the organ level. So it is what we call multi-scale analysis, from molecules to the heart. And so the matter is that we've got now genetic tool to modify the cells and to understand what's happening in a single cell, like a cardiomyocyte. But understanding that is not always sufficient to clearly decipher which mechanisms are the main involved in the pathology at the heart level. So what we need is different tools to study the molecules, but also how these molecules and the different cell types are interacting at the heart level. Because one of our aim is to understand which mechanisms or which molecule are deregulated in the core of the ischemic area, or in the periphery, or even in the healthy area. We've got to be able to label and report their expression in the organ. Thanks to X-Clarity, we can now have an access to the three dimension of the whole heart organ. So when we are using fluorescence microscopy, so this is a great chance because we can replace the expression of different markers in the context of the whole organ. With this clarification technology, with mouse heart, we can now making to be mostly transparent, and with fluorescence microscopy, we can record images of slices achieving the heart, and so after that, with computing treatment, we can reconstitute in 3D. What we aim to do is, from X-Clarity, clarification of the heart, to fluorescence microscopy, and to computing analysis, what we aim is to provide a chain of method that is giving reliable quantification of the ischemic area, of the area at risk, and of the left ventricle volumes. We also expect that in the future, this chain of method we are trying to set right now will be a good tool for our colleague worldwide. We are also having some trials on different organs to see if we can just generalize this kind of strategy to something else than heart. Brain, for instance, in the case of stroke, because it is almost the same. It is expected to be almost the same mechanism. So probably we could use the same chain of methods.